guys, go through what we actually normally cover into this course. This is the 5-day overview of the 5 days that we cover when we do an online PLC course. I'm going to go through only module number 1 today. What we will do is we will build a small exercise. We go creating a project, and then we will do the exercise built into that project. Okay, but I'm going to go through a lot of the theory with you. Okay, normally we ask questions. I like to know the guys, if you guys can maybe put it into the chat so I can see it later on. Are you electrical, mechanical? What is your background? And do you have any electrical, mechanical instrumentation background? Do you have any electric pneumatic background? And then also write down quickly, what is your background experience about PLCs? And yeah, I normally ask what is the expectations, but I assume you guys want to know about PLCs. Okay, guys, starting off with what we can cover for today. I'm going to try my best and see within this hour if we can cover all this stuff. It's codices, because we utilize codices, the software 3S company that developed codices. It stands for Control Developed System. That's a software that we use. And we use currently 3.5 Service Pack 17 on my PC. I will also go through, help you to create a small project, the creation of the global variable list, and then we could go through all the windows and the tools that exist inside, and then go through a basic program within ladder, and then also how do ST works. That is the structured text. That's what I will cover for today. Okay, guys, what is codices? Now, codices is actually a standard within the industry, and some of you guys are maybe familiar with codices as a software. Like I said to you, 3S smart company within Germany that actually have developed the software, right? And this is what they say: device-independent PLC program system developed by the Smart Software Solutions. It also matches, and very important for the industry, that matches the IEC 61131-3 standard. That means codices is a standard. And like I've mentioned to you now, it's developed by a company. It's not based onto a PLC or allocated to a manufacturer, but it's actually an open source software that you can download for free, and you can start utilizing the software for programming, and then also for configuration and for programming within a PLC. The software is always available for free. Like I said to you, more PLC vendors is using it. Festa is one of the users of the codices. It's also becoming a standard within PLC programming, right? And like I've mentioned to you, that's the old version was version 2.3, and the new version is 3.5. And currently I'm using Service Pack 17. Okay. Right, that is a little bit background. Here's all the IEC programming languages that exist within codices. Starting off with number 1, it's ladder, that everybody knows. It's similar to a ladder, electrical drawing or electrical circuit. Okay, and then sorry, and then number 2 is what we call or refer to as function block diagram. Then structured text is number 4, but that's the 2 that I'm going to concentrate, number 1 and number 4. The rest is, for example, number 3 is your instruction. 5 is what we refer to sequence function charts, and then number 6 is continuous function charts. This is the 6 programming languages that exist within the IEC standard: ladder diagram, function block diagram, instruction list, structured text, and then also sequence function chart. And then you have your additional programming languages called continuous function chart. And then there's also a way to actually page orientating your program when it comes to your CFCs. Okay, that is the 6 programming languages. Right, we will concentrate today only on 2 of them. Right, now I'm going to start off by explaining to you what is a PLC. If you don't know a PLC, Program Logic Controller. And I'll make a statement. Yes, I'm going to show you how to understand the fundamentals of literally any PLC system. That means any PLC works on the same basis. It's really just one part of the larger path. And I'm going to show you and walk you through all the important steps and the nuances that you need to know right now to understand any PLC system, right? So there are three elements, very important to know. There's three elements that you need to understand to get to the fundamentals of any PLC system. Okay, so there are three elements. First thing is your inputs, then your logic. That's your logic is the program or your thoughts when it comes to your program, and then the outputs. That's the three basic components or elements into a PLC. Right, to understand what is the inputs. For example, a PLC controller is like your brain. Right, it needs an input before it can make a decision or do anything. All right, now let us use this as an example. For example, you inputs into your brain are your 5 senses: sight, sound, smell, taste, and touch. That means that's how your brain actually sense. And then onto that sensing, but you then you react onto the sense. That's what you sense. Okay. For example, if I can use this an example, you approach a robot, a traffic light, and the moment when your sight sees you need to stop, that means then your output will be to put your foot onto the pedal, your brakes, and you stop your car. Right, that means that's how a PLC also works. There's inputs, your thoughts, and that is what your brain is. That's the brain of a PLC, and then the actually result of the decision that is made within your PLC will be then also onto the outputs. Okay, that means that's basically the inputs, your logic and your outputs of a PLC. That means if I can take it a little bit closer to the industry, right, to get a clear understanding. So there are three elements, like I said to you: inputs, logic, outputs. Okay, let me discuss with the inputs. For example, now if you have a garage door that are working automatically, for example, the input is like a sensor on a garage door. That means the input, right, when it senses the sensor that it stops the motor. That means the moment when it comes close to closing your door, there's a sensor. The sensor senses that you approach the end of your door or the closing of the door. That means then it stops your motor. Now, that's exactly how a PLC also reacts or works. Most inputs to a PLC are things like push buttons or proximity switches, like your garage door. Sensor that stops the door before it crashes your kid's bicycle. If your kid's bicycle is there, and it actually stopped. They are so-called, now all the inputs are so-called discrete inputs, meaning that they are either on or off, not anything in between. It's only either on or off. That means, okay guys, that means then, let me quickly go through a few examples of input components or elements, okay, like limit switches. Right here, I've got now a limit switch. I've got proximity sensors. That can be a capacitive sensor, inductive sensor, optical sensors, right? Optical, a capacitive sensor, ultrasonic, or any auxiliary contacts, or any push buttons, start or stop push buttons, or emergency stop. That's all the different types of inputs that you can actually wire onto a PLC. That is the input part. All right, that's the inputs. Then, for example, the push button is one of it. Like I said to you, a limit switch that senses the position of a garage door, or a proximity that senses, for example, a component or a metal object. All right. You can also have an optical sensor, have a much longer range as a proximity sensor. That means you can actually sense from a distance, or any optical sensor that actually, when we want to know where a box is on a conveyor, for example, we can sense that the object is actually on a conveyor belt. All right. Then you got, for example, your capacitive sensor. The capacitive sensor are like proximity sensors that sense non-conductible materials, for example. That means that's also one of the input components. Ultrasonic, solid for solids, to measure solids within a bottle. Okay, right, and then any auxiliary contacts of a motor, right, or a system that you want to control. Okay. Now, guys, you also get what we refer to analog signals. Now, the inputs is digital inputs, or we can also talk about analog inputs. Now, this is an example of analog components like thermocouples, pressure switches, humidity sensors, any analog proximity, right, that actually measures a range or a voltage or a milliamps or any range that you want between 0 to 10 volt or maybe minus 10 to 10 volt. Any analog component that can measure something to you, that can be wired into a PLC. That's also part of the inputs that you can wire into a PLC. Okay, now guys, for example, when it comes to the comparing of what is an analog, what's a digital, right, we can actually talk about digital inputs now, and a digital input can be a 1 or a 0. Now, we may refer that to an on, or we refer to as a true. 0 is off or false. That's on my input side, on the digital input side. Analog signals is, for example, 0 to 100% or 0 to 10 volt, or maybe 0 milliamps up to 20 milliamps. It depends on your range of your transmitter or your actually measuring device. Okay, now that means there's two types of signals. Like I said to you, if I've mentioned to you digital signals and analog signals, okay, that can be wired as an input into the PLC. Right, now let me talk about your inputs, for example. Now we talk about binary inputs. Binary inputs. A binary is a value between 0, right, and 1. That means it can be 1 or it can be 0. It can be on or it can be off. Like we said now here, digital signals is off or false, or 1 is true. Right, now there they give you an example of it. Right, a binary signal. All right. That means now analog signals, for example, PLC can also analog inputs which are more like light dimmers you might have in your house, for example. Instead of on and off, it can be somewhere in between. All right. For example, when it comes to your fuel gauge on your car, can be empty, or it can actually be anything from empty to full. All right. That's actually the analog signals. Right, and then also onto when it comes to PLCs, like I said to you, your sensors, you can actually then also control a system or a process. All right. Now, logic in the PLC. Now, I've discussed with you all the input side now. Now, the logic. What is the logic part? Where magic happens, guys. That's where all the magic happens, by taking your inputs and making some decisions, so that you can perform some actions with your outputs, just like you're programming your brain, right? Like I said to you, you approach a traffic light and you sense that the robot or the traffic light is red. You need to stop now. You make a decision by putting your foot onto your brake, and you stop your car, for example. That means now the logic part, or the logic, is your decisions. You can program a PLC to make decisions and produce actions, for example, stopping at the red light, like I've mentioned to you before. Okay, now guys, here is a few things that you also need to understand when it comes to a PLC. Like I said to you, the programming that I've mentioned to you, the programming languages that I've already mentioned to you, you can be programmed in different languages, like ladder logic or structured text. Now, that is the two that I'm going to discuss with you today in this course. The programming language does not matter much. It is just a way to tell the PLC, right, what to do, or the controller what to do with all the inputs it's getting. That means, guys, the program and the programming language is normally the languages that the guys like and understand and are familiar with. Now, the basic one that I've mentioned to you already is the ladder language. Ladder is a typical example of a diagram language, like electrical circuit, right? And like I said to you, it also matches the IEC standard, right? 6113-1. 61131-3. Okay, that's the standard. Okay. Now, let me quickly talk about your ladder diagram itself as a program into the logic part of your PLC. Okay, that means you will check right, we talk about normally open contacts and normally closed contacts. Now, what does normally open means, and what does it normally closed means? Within a PLC, a normally open means like a relay have contacts, normally open contacts and normally closed contacts. The moment when you energize a relay contacts closes, that means a normally open will close or a normally closed will open. Now, what does that mean within a PLC? It means that you check for a on or you check for a off, or what we refer to, we check for a 0 or we check for a 1. That means when it comes to a normally open contact within a PLC, within a ladder diagram, for example, within your logic of the PLC, it means that the moment when you start programming and you utilize a normally open, you want to check for a 1. It means if the real contact within your plant or within your system or your machine closes, it will close also within the PLC program, and that sense that it actually is on. That is a 1. And if you utilize a normally close, when I activate a normally close, it normally opens. That means then we sense for or we're checking for a 0. Okay, and then you have the output part, and that is the coil. That is our coil. That is actually the part that you want to put on or you want to put off. Okay. That means the ladder diagram is one of the most common use, and a lot of people actually like to utilize ladder as the referred programming language with the PLC. Okay, now guys, then also static text. Now, if I can actually explain to you static text, you have what we call conditional parts and execution parts. The conditional part is what you check for. That means if the switch is on, and then your execution part is then you say, right, if the switch is on, then your lamp must be on. Okay, that means on. That means the basic language of static text is as what Pascal and maybe C# and C programming also utilize, if and then instructions. That means the if and then instructions. And you can also add later on to more advanced, like if this, then this. Okay, all right. Now that is basically the two languages that we're going to talk about, and I'm going to quickly demonstrate it to you later on again. Okay, guys, here is outputs. For example, if the PLC receives an input saying that a motor is running, you could have a logic that turns on a light onto the front of a panel that says motor running, which leads us to the output part. That means like lamp indicators. There you have, for example, here we have all your lamp indicators. This lamp indicator is going to receive a signal from the PLC or from a PLC controller. Okay, you could also have electrical motors that you want to put on and off, alarm or a siren, or you can also do it with pneumatically. You want to actually operate a machine that have valves onto it, and a valve operates or actuating actuator. We utilize, for example, either two-way double solenoid valve or a single solenoid valve. All right, that's the output parts of a PLC. That means I said to you the input parts is all your input sensors. Then you got your logic part, and then I've got my output part. Now that's the three basic elements of a PLC. Okay. Now if you put this three together, for example, here is now a basic explanation of how a basic working principle of a PLC is. You got your input modules. In some cases, guys, when it comes to PLCs, if you have worked with it before, you will know this. There is an input, there's an input component or a card, input card, that you wire all your input devices onto. Then you have your CPU, that's your processor. And then the processor are then connected to an output module or an output card. And then the output card are connected to your output devices. All right. That means there's basically, if I can draw up a block diagram, we got your inputs, we got your processor, and we got the outputs. Now, the supply, power supply is sometimes it's actually built into the compact PLC. For example, the Codesys PLC that we use, the CECC PLC, is a compact PLC. your power supply, your CPU, your inputs and outputs are built into one component. They call it a compact PLC. Or you can get a PLC what have modules, and this is what this represents. It represents input module, output modules, and then your processor, your CPU, your central processing unit. Right, and that means you connect your inputs to it and your outputs to it. Okay, now basically what your PLC do is when you start your PLC, when I start my PLC, the moment you give it power and you want to run the program that exists inside your PLC have sometimes that have a mode selector. That mode selector, you actually put it into stop mode or into run mode. If the moment when I put my PLC in run mode, I'm starting executing the program that I've loaded, I've downloaded it into my PLC. Now, what happened is, in a certain sequence, there's a few things that happens in a sequence, right? For example, cycle program execution takes place. The start of the program, you call and execute of your after power on. All right, and for example, then built into your processor, there is a memory area called a PII, process image input table. There's also a process image output table that are built into your processor. Right, now what is the PII? What is the PIQ? The PII is a table where you can register, or what we refer storing your input, all the input devices that you are wired onto your PLC. The conditions of the inputs are stored within the PII table. And then you have also your PIQ table. That is for actually writing your result of your program that you have done into your PLC are written into. That is memory area inside your PLC. You store your conditions of the output conditions within your PIQ table. Okay, now basically what happens is the moment you start the cycle of your PLC, it runs in cycles. That is the moment when the cycle starts, or what we call a monitoring of the cycle of your PLC. You read the input statuses from the digital input modules and save the status into your process image input table. Right, then you have a main program. Your main program are normally loaded within your task configurator. Then the task configurator can call a POU. What is the POU? A POU is called Program Organization Unit. Okay, it means that the Program Organization Unit have your logic thinking in. That means your program, your ladder program or your structure program will be, you will do that within your POU. And your thoughts, your logic thoughts will be written in there. And that means the moment when you start your PLC scan through your PII, execute your program, your result of your program will go to your PIQ, and then you start over again. That means, and that happens continuously within your PLC. That means there is a cycle, and your PLC CPU cycle through your program. Okay, and that's the basic working principle of a PLC. It means at the beginning of the scan cycle, what we refer to as scan cycle, you scan for the inputs. Where do you look for the inputs? The inputs conditions are within your PII. You execute your program. Your result of your program will go to PIQ. And then from that moment, the PIQ will then send your signals out to your output devices. All right, and then you start over again. Check the inputs, execute your program, and then the result will go to your PIQ, your outputs. And that is how the PLC cycle through your program, and that's continuously happening during the run of your program. Okay, now guys, here is an example of what I've explained to you now. You have it, what we call the process image. Right here we got the process image input table, the PII. We got the process image output table. Right, then inside the middle is your user program, what I refer to your POU, your Program Organization Unit. Okay, for example, I've got now an electro-pneumatic small circuit here, where we have an S1, that is a sensor, and then I have K1, that's a relay. For example, the moment when you S1 is going to be closed, that can be an input, and then the relay will be your output part. Now, here is an example of a small little, actually ST, structured text, not structured text, what we refer to STL, small little STL program also. I'm scanning, that means and is the scanning to check what is the condition of input 6.4. Where do we check it? We check it within your PII, right? If that is on, then I want equal is to put the output on. Where do we put it on? We put it on within my PIQ, right? And this is now how a PLC cycles through your process all the time. In the beginning, you check your inputs, write the result of your inputs into your PII, execute your user program. Then the result of your user program will go to your PIQ. The PIQ will send out your result to your output modules. Your output modules will go to your physical outputs, and that puts it on. And that's how a PLC actually scans through your program. This is the program execution, cycle program execution within a PLC. We can go into a little bit more detail when you're actually attending this course. Okay, guys. So for example, here is an example of an exercise that I want to do this afternoon. Okay, this exercise is a warning lamp is activated by means of a switch right at a remote location. The warning lamp stays on as long as the switch is activated. When you're deactivating the switch, the lamp switch off. Okay, for example, now let me put this into a PLC now. Right, I'm going to actually then move over to the software. Right, I'm going to open my software. Give me a moment. I'm going to open my software. Okay, guys, like I mentioned to you, we're going to use codices. And I'm currently using, like I've mentioned to you, codices actually 3.5 service pack 16, patch number 4. Okay, give me a moment. I'm quickly going to switch on my software. So I'm going to share my software with you. Hold on for a moment. Okay, we can close this. Okay, right. I assume you can see my codices on this.
We can see, yes. Thanks, Davi.
Okay. Right, guys, now listen to me. Now I want to put everything that I've discussed with you into actually more a practical understanding of the PLC itself. Okay, here we got now the codices open. Right, now to start the codices, normally, if everybody understands this, you install it onto a PC. It's a Windows-based program. And then you go to your icon, you double-click your icon to activate the software. And right, now within the software, you go to your menu bar on top to File. And I want to start off with a new project. I need to put a project within my software. And then I'm going to actually add within the project, I'm going to add a device, okay? That means I'm going to click onto new project. Right, now here is the options. You got empty project. I will start off with an empty project. I will give it a name. I'm going to call this intro to PLCs, intro to PLC. Okay, and I will put today's date today, and then that will be 7/8/22. And say, okay, now right there. That means now I've started a project with a project name. Right now, within this project, I need to add myself my first component, and that will be my CPU. All right, I'm going to right click onto it, insert and add a device. Okay, now let me explain to you. I'm going to utilize today the internal PLC. That means the software PLC, not a hardware PLC, but the software PLC. Right? From 3S Smart Software Solutions, and it will actually then be part of the installation. When you install it, the software, it will be part of the installation. I'm going to click onto this. I need to go down to your Win controller. That will be the Win controller. I'm going to utilize 3.5/16, add that into my device. Right? Right, there it is. That means I've added a controller into my project, right? And now I need to double click onto that. Right, if I click onto it, I need to actually connect to it. That means there must be an interface, all right, to connect to that interface. Guys, now how you do it, this is the moment when I click onto gateway and I say I scan for it. Now, what you need to understand is because I'm utilizing the internal PLC, I've put the internal PLC on already. Give me a moment. I quickly want to go to minimize this. I want to make sure that I put my system on. Give me a moment. We're going to make sure that I put my PLC on. All right, my PLC is on. Okay. Give me a moment. I'm going to share my codices with you again. Okay. Can you see my codices on this?
Yeah, we can still see the other things.
Okay, now here's a problem with my system. Okay, hold on for me. Okay, guys, give me a moment. Quickly, I'm going to fix the problem that I've got here with me currently. Okay, let me close this again and then open it again. Okay, oh, goodness. Okay. All right, guys, give me a moment. If you're going to close this now, if you don't mind. Oh, right, honest. I can tell you a little This will be a guys, I'm going to start it again. Hold on for me for a moment. I'm going to start my system again.
Restarting.
No, it's already starting. It's really starting on us. Thank you. Okay, sorry for that. It was a small problem that I actually. Okay, yes.
Okay, I just want to find out: are you simulating a real hardware PLC now?
Yes, I'm doing it.
Okay, so that is what you're explaining to us now, and that is also the way that the guys will do it on the webinar. If they
on the webinar itself, what I will do is I will, if they don't have a real hardware PLC, I'm going to use a software PLC that's built into the software, and we will utilize the internal software PLC to do the programming. Okay, guys, I'm back here. I'm just going to add it again. I hope you can see this. Honest, my codices.
Yes, I can see codices with intro to PLC as a device.
Okay, hold on for a moment. I'm going to quickly change something here. Okay. All right. Okay, there it is. I'm adding it into my system. Okay, guys, now here's my PLC. I'm going to quickly click on this one. Right, click onto this gateway and then scan for the network. Right, there it picks up my PLC. Here you can see my PLC. That's the PLC.
Tommy, sorry, yes, we can only, the screen that we see is got intro to PLC and just with a gray screen at the moment.
Okay, but now.
There we go. Thank you. We can see now.
Okay, thank you. Right, guys, check here. What happens is the moment when I click on my gateway and I click on the scan, that's the way that you will also connect to a real PLC by clicking on the scan. And if you have set up your interface, it will pick up it automatically. Okay, there it is now. Right, now that's the hardware that I've actually picked up now, for example. Right, now within codices, right on my left-hand side on the codices, within my device window, I need to add a task configurator by right-clicking on application and adding a task configurator. Right at the end, you will see a task configurator. Right, that is the main part. Yes, sir.
I see the application on the left-hand side and library manager. Is that still correct? On the right-hand side, on the screen gateway and my PLC. But
on your right-hand side?
Yes, but I can't see your cursor at the moment. Let's just make sure
that
we no.
Is there anything? Can you see it now, Honest? Can you see codices?
I see codices. Intro pack, yeah, 20. There we go.
Right.
Codus
What
is
you're supposed to see now is you need to see a window, a device window.
I see
that?
Task window, yes.
Right, that's it.
Thank you.
Okay, right, guys. Now, within the application, can you see application on this?
Yes, I can see application on the left-hand side.
Okay, excellent. All right, guys, now check what happens within a task configurator itself. I need to go to click on task configurator, and then I'm going to add myself my program, right, by application, and then click add, and I'm going down to POU. Right, what is a POU? Like I've mentioned to you, is what they said, program organization unit. Now here we can select all the languages that I've mentioned to you earlier on. That's all the languages that we can actually select. I'm going to select now the ladder diagram language. We're going to do a program, not a function block. Later on, if you're actually attending one of our advanced courses, I will explain to you what is the difference between a function block and a function and a program. I'm going to utilize now only a program. I'm saying adding it. Right, the moment when I do this, this is where I got now my option now to start programming. Okay, now before we do that, for example, if I actually, like I've discussed with you, we can actually utilize that, the PowerPoint. I've showed you the PowerPoint, and I showed you we need to use a warning lamp. Okay, and that means I need to declare, very important to understand this, I need to declare my inputs, my outputs, within what we refer to as a GVL, a global variable list. Okay, I'm going to right click onto application again, insert.
Okay, Darby, sorry, we can't see your screen currently. Oh, we see it, but I can't see what you are doing.
I don't know what, why is it happening with this? Can you see it now?
There we go. Okay. I can see program POU, var and endvar. That's what we can see.
Okay. Right click onto application, and I'm actually want to add myself a GVL, what we refer to a global variable list. Okay, now what is the global variable list, guys? That is where you allocate symbolic names for the inputs and for your outputs. Okay, that means I'm going to actually then open the space in between the variable global and end variable, and I'm going to put there, for example, my let me say this start, call it a start, and then a colon.
I think there's a little bit of a lag because once again we can't see what you're typing there.
Okay, but give it
could be network or something.
It will be, maybe it's the network. Can you see while I'm typing now, Hannes?
No, unfortunately not.
Okay, no, I cannot help myself. I don't know how to do it. All right. Okay, hold on for me for a moment. I'm going to share it with you again.
Yeah, David, I think just stop sharing. There we can see warning lamp. We can see that now, yes. Okay.
All right, guys, the two symbolic names as bools, or what we refer to binary. Okay, there's the two components, right, that I've actually now allocated. Now that is, for example, now an input and output. The start is my input, the warning is my output. Okay, and now I can go into the POU itself. Okay, and like I said to you, I'm going to utilize now on my right hand side, you will see that the toolbox. Okay, my toolbox is for the your ladder components.
David, sorry, can you perhaps just stop sharing and share again? I think there might be a glitch with Zoom.
And let me quickly do it right again. Hold on for me for a moment. I will quickly do it again. You cannot, nice, okay. Did I share again with you? Right, click on sharing.
Not yet.
Right, sharing it again. Can you see it now, Hannes?
Yes, I can see. I can also, I can see your cursor now, so I think the image is live now. Thank you.
Everybody can see it now. Okay, guys, what I'm going to do is I'm going to go to my toolbox. Okay. And then within my toolbox, I've got my ladder elements. I'm going to utilize a normally open contact, like I've mentioned to you that we check for a 1. I can use a normally open contact, right there, and then click it there. Right there where the question mark is, that's where you allocate your symbolic name or your physical input, right? Because we are not connected to a real PLC currently, I'm utilizing now the symbolic name, right? And that will be my start, for example, right? Here's the start, right? There's the start. All right, let me quickly explain to you what's going on here. Okay, if you click it onto the small with the 3 dots is, clicking onto it, I can go to application and I can go to GBL and I can click onto the start and say, okay, that is now my start. That is the start. That will be like an input or a push button. And then I'm going to go to my toolbox again. And then I'm going to go to the coil, sample, grab a coil, click there onto it, and then I'm going to add where the question mark is, I'm going to add my warning, right? And that's my warning lamp. So, okay. Right, there is my small ladder program. Okay, now guys, there's a way to test it if you don't have a real PLC. Like I've mentioned to you, we're utilizing now the internal PLC. If I want to test my program or test the small little ladder diagram program, okay, I need to go to build and building it. That is to check for errors. Now, if you check here right into the corner, you can see that there's no errors, right? And then I can go to online and then multiple download. That is to actually allow the program that's currently within your PC to download it to your PLC, for example, right? And it tells me it's downloaded now, right? And then I'm going to go to lock into the PLC. That means I'm going to start the software to visually actually monitor what's going on within my PLC currently. I'm clicking on that icon then, and that means now check what happens here. Now you can see that there's nothing actually that's currently on. Why? Because we don't have physical inputs and outputs, but there is a way to test it. That means now if I'm going to go to the GVL, for example, right, and I want to actually then switch it on, let me quickly check if my PLC is still fine. It's all right. The PLC is still fine. Can you see it, Hannes? You still see my software?
No, Davy. We see
Okay.
your variable global list.
Why is that now? Okay. Hold on for me for a moment. I want to see this. And can you see my program now?
Yes, I can see.
Okay, great. Right, guys, now what I'm going to do then is I'm going to add in onto this, and this is what we also do when it comes to the training, during training. We add what we call a visualization, okay? I'm going to right-click onto application and add the object, and then go down to the end where I've got a visualization. Now, if I can actually explain to you what visualization means, a lot of people know this as an HMI or human machine interface software, okay? Is to actually simulate what we actually want to put on or off. Okay, I'm quickly give it a moment for the visualization to be created. Sorry, my software is very slow. Give it a moment. Okay, after I've actually, if I've added my visualization into my project, give it a moment, it will be now shortly there. Okay, there it is now. Now I can go to click on my visualization, and you will see now within this blank screen here, I can go to visualization tools onto my toolbox, and I'm going to then add myself, for example, let's use a dip switch. All right, drag it over to there, click onto it, and then it's okay there. Right, make it a little bit larger, right? And then I'm going to also utilize a lamp. Okay, a lamp, and then actually then put it there right here. Right, now I need to connect this two physical objects, right, the switch and the lamp, onto the physical inputs that I've actually have declared within my GVL. Right, that means I'm going to click onto this one, right click onto it, all right, and that means now I'm going to go to properties, check here on the properties side, click on the properties of that object. And then within the properties window, I need to attach the variable name that I've actually declared within the GVL onto this dip switch. Okay, that means you're right here where I'm now clicking there, and goes into this. Right, I'm going to click there in this and go to the application to the start and say okay. I'm going to do the same thing for the output part. Onto the properties, click onto the component or the object, and then go to variable, and then do exactly the same thing as what I've done for the inputs. This is for the output part, the warning lamp. Okay, there it is. Now I know that if I click onto the properties of this component to make sure that the start is there, right? You can see the start is there. And then if I click onto the output, the warning lamp will also then be there. The warning lamp will be there. Okay. Now that means now I've actually attached the physical input to my object within my visualization. And I'm going to go to building it now, and then also download that into my PLC. Give it a moment. I think the system is slow because of all the software that's open here. Okay, I'm going to quickly download that also within my PLC again, within my online PLC. Okay, I've done that already. All right, now what you can do is if I go to lock into the PLC, click onto the lock onto the PLC. Okay, now you can see now if I click onto this one, I'm switching it on. Okay, and now to make sure that this are attached to my PLC itself, okay, I'm going to go to the Task Configurator and then add my call. Right, now this is how you add the call within the POU. Okay, there it is. Right, now the POU are actually settings. Okay, quickly, I'm going to quickly go offline first. Sorry, I need to go to offline and then click on call and then click on that one. And there it is now. There is my POU now within my task configurator so that I can actually physically test the program now. I'm going to go to online, build it again and then download it into my PLC again. And then I'm going to test the physical outputs. Okay, go to online, multiple download. So, okay. All right, there it is now. It's downloaded into my PLC. I'm going to go back into the POU. I'm going to go to log into the PLC. Okay, now you can see that there's a start, but if I'm actually going to now go to the visualization, hold on for me quickly. I'm going to quickly do it for you like in such a way that you guys can see what I'm doing. Okay, I'm going to go to Windows and then open them both. All right, make it vertical. Okay, and now check what happens the moment when I press this on. Right, there I'm putting the input on. That is the start. And then my warning lamp comes on. And if I can put it off, on and off, that means now this is how you utilize the internal PLC, right, that exists within the software, all right? Now, this is a basic ladder program, all right? And that means we will take you step by step through everything and explain to you exactly what I said to you previously. What happened is, the moment when you put your PLC in run mode, it scans your PII, write the result into your PII table, execute your user program. The result of the program will go to your PIQ, and the PIQ will actually then send out your result to your physical output. And that's actually a small little ladder program. Okay, I think that's everything from my side, guys. Hannes, can you hear me?
Davy, yes, thank you. And yes, we realized that you only had like 40 minutes to do this, but thank you so much. Guys, and as you can see, it is when you do attend a practical webinar, the 5-day webinar, each participant will download codices on his or her computer first. And while Davy is doing it on his side, the participants will do it on their side as well. And if there are any questions, they can interact with Davy the same way that I'm interacting with Davy at the moment. So it's really a very, I think PLC is one of the easiest courses to do online because in a practical face-to-face class, you are also doing it on your own PC or laptop. So I think PLC webinars are one of the easiest type of webinars to do online. And that is actually what we wanted to show you. But Davy, thank you for the overview. If it's the first time that someone is encountering PLC or PLC technology, I think it's a great overview of what you've showed us. Guys, what I'm going to do is I'm just going to share my screen quickly. Are there any questions at this stage with regards to PLCs or with the PLC training specifically? If there are no questions, like I say, I'm just going to share my screen quickly with you. Davi, you can just tell me if you see my presentation screen there. Davi, can you see my presentation screen?
Yes, Hannes, I can see it.
All right. Okay, thank you. So guys, just quickly an overview. We've got 5 minutes, 6 minutes left. We really try to offer our customers a complete blended learning experience and opportunities to upskill. So first of all are the face-to-face training courses. A lot of you might be familiar with it, but obviously at the current environment and of COVID, it's not ideal to do face-to-face training courses. A lot of customers are still doing it, but they prefer to do it in-house so that the people who's working together every day on the same training course. Then we've got our interactive practical webinars. The one that Davi showed us now, that will run from 8 to 10 from Monday to Friday. So you've got 10 hours of interaction and learning that you will do on the practical webinars, with a little bit of homework just to practice what you've learned that specific day. And then we've also added now a new platform, online training courses. We call it Festo Alex or Festo Learning Experience. And that is exactly what I want to talk to you about quickly. So just to get back to the face-to-face training courses, obviously that is our the first prize, because you've got maximum interaction, there's practical hands-on experience, and a lot of those courses are also CPD accredited. The technologies that we are covering there is pneumatics, that goes from basic electro-pneumatics up to fault finding, which is fantastic, energy saving. Then we also have hydraulics, PLCs, codices and Siemens face-to-face training courses, electric automation, process automation, actuators, process valves, water treatment. And the pinnacle of the training courses is robotic and mechatronics, which is a combination of pneumatics, e-drives, PLCs, where you really get to put all the technologies together. The webinars, once again, also interaction with a facilitator. So it's not the webinar where you sit back and it's death by PowerPoint. Whether it is pneumatic, hydraulic, or the PLC webinars. Those of you who have attended some of the other webinars before, you will know that very interactive. The software that we use on the pneumatic and the hydraulic webinars is called FluidSim. That is really simulating pneumatic and hydraulic circuits and designs. So you build your own circuit. Each participant has got a FluidSim license. You build your own circuit, simulate your own circuit, fault find your own circuit, different settings, flow controls, pressures. Really a very fantastic and intuitive type of simulation equipment or software. And then obviously on the PLC, we would make use of codices itself. With regards to the online training courses, Festo Alex covers the topics that you can see there, which is electricity, fluid power, industry 4.0, factory automation, which includes pneumatics and hydraulics, electric power technology, motors, variable speed drives, metalworking, process automation. So a vast amount of technologies that are covered on the online training courses. Now, the benefits of that is it's cloud-based. So you are not stuck to one component or one device. You can either do it on your laptop or PC or log in on a tablet or your telephone and do it anywhere, anytime. There are over 200 courses to choose from. I think there's about 105 courses that you don't need any hardware equipment for it. There are also courses that are linked to our learning systems equipment. You can see, sorry, no, you can't see that picture yet at the moment, but the learning systems equipment like pneumatic rigs or hydraulic rigs or electronic components that you have that you can link up with those courses. But like I say, over 100 courses that you can do without any equipment. It's economical and convenient. The nice thing is you can customize the content. It's self-paced. There's progress and result monitoring. And as I mentioned, multi-device participation. Now, just a quick overview of how it works. So Festo, Alex, you will create the courses for your employees, for example. In your company, you will assign different courses to the employees. They will start learning. There's monitor progress and support. And then at the end, there are some assessments, and you will rate the success of the employees. As I mentioned, there are standalone e-learnings for theoretical knowledge where you do not need any hardware. Then we've got our eLab courses where you make use of the learning systems hardware if you do have. And then we've got our evaluation courses where you can monitor the progress. So it comes in packages of 25 licenses, and it works out a license per year for about 1,600 Rand, which I think is absolutely fantastic if you take into account that there's over 300 courses that you can do for 1,600 Rand. Now, I would like just to show you quickly what it looks like live. This is what it looks like. If we go on search, I'm not going to go into detail, but you can see electricity and electronics, fluid power, factory automation. If we do look at fluid power, you will see there's pneumatic fundamentals. Let's just have a look quickly at pneumatic fundamentals. You will see there are some learning unit 1, introduction to pneumatics. So there are all the fundamentals. What is air? What is pneumatics? Some more nuggets that you've got there. If we have a look, if I run the course, just to give you an idea of what it looks like. So I'm just going to switch off the sound on my side. So there's a nice video of pneumatic applications. All right. So this is all part of just one of the courses. What is pneumatics? What is air? Origin of the word pneumatics. Like I say, I'm not going to go into detail. We've run out of time, but this is really an option to upskill you or to upskill your employees for a very, very economical, at a very economical rate. I'm just going to stop my share here. Have you seen anything